Hello, my lovely viewers. You are welcome again. In this video, I'm going to talk extensively. I'm going to explain in details what RCD is, what it does, what the difference is between RCCB, RCBO, how they operate. This and many more I'll be talking about in this video. And I bet you are going to learn a lot of new things you have not known about the RCD in this video. Enjoy watching. All right, so RCD is like a family name. RCD actually means residual current device, and that is a family name for a number of residual current devices. But I'll be talking about two of these family members that we normally use in our electrical wiring. All right. And the two I'll be talking about are the RCCB and the RCBO. So practically, what we actually use in our wiring is either RCCB or RCBO. RCCB means residual current circuit breaker, and RCBO means residual current circuit breaker with overload protection. All right, so let me start by explaining how the RCCB works. Okay, so basically, when an RCCB is connected in an electrical wiring or in an electrical circuit, what it basically does is that it monitors the amount of current that is flowing through the live conductor and then back through the neutral conductor, and makes sure that at all times the amount of current that is going out through the live wire is the same amount of current that is returning back through the neutral wire. So the RCD makes sure that this condition remains the same. As long as it remains in the circuit, there shouldn't be any imbalance, there shouldn't be any leakage. All right, what is imbalance and what is leakage? Imbalance is when the amount of current flowing through the live conductor becomes more than the amount of current flowing through the neutral conductor, and vice versa. And anytime the RCCB senses an imbalance in the current flow in the circuit, it will operate to disconnect the supply from the circuit. So it monitors the circuit and makes sure that if it is 2 amps that is flowing out through the live wire, the same 2 amps should return back through the neutral wire. The moment there is any imbalance, the RCCB will operate to switch off the supply. All right, so imbalance, leakage. How actually does the RCCB protect human beings from receiving electric shock? Let's look at that. Before we continue with that, we have to look at how a human being can receive electrical shock. All right, so there are two ways that human beings can receive electric shock in an electrical wiring. And that is one, through direct contact, and then second, through indirect contact. Direct contact means that you have contact with a live conductor. Indirect contact is when you have contact with a metal part of the wiring that is not supposed to be carrying current under normal circumstances. But when there is a fault in the wiring, example, when there is a leakage in the wiring, that metal part that is not supposed to be carrying current under normal circumstances now becomes live. And so when you have contact with that metal or that item, you can also receive electric shock. And so that is what is meant by direct contact and then indirect contact. Now, for a person to receive shock under any of these circumstances, there must be a flow of current through the human body to ground. Before you can receive the shock, an amount of current should pass through your body to the ground. And because the RCCB is in the circuit, the moment that current flows through your body, the RCD will operate to switch the supply off. Because when that current that is supposed to pass through you and give you the electric shock is flowing through you, in that case, the amount of current that will be flowing through the live conductor at that particular moment will be more than the current that is returning back through the neutral wire. And so that creates an imbalance in the circuit, and the RCCB will operate, and that saves you from receiving the electric shock. When we talk of leakage, leakage means that a part of the current that is flowing in the live conductor is now leaking and it's flowing into other metal. And so when you have contact with that metal that is now electrified because of the leakage, that current in that metal wick can pass through you to ground. When that happens, that creates an imbalance in the circuit, and the RCD operates to switch off the supply and to save you from receiving shock. All right. The next question is, the RCD, does it have a rating? Are there different ratings of the RCD? And what do those ratings mean? Yes, the RCD has ratings, and how fast the RCD operates and how best it can protect you from electric shock is dependent on the rating of the RCD. And so the rating of the RCD is one thing you must be careful about. Otherwise, you may have an RCD in your electrical wiring, but it's actually protecting no one from electric shock. All right, so generally, there are two ratings on the RCCB that you have to be mindful of when you want to buy one. All right, so there is a rating that shows how much current the terminals of that RCCB can handle. And there is another rating in milliamps that shows how much fault current or how much leakage current can cause the RCB to operate to switch the supply off. All right, so now how do I know the correct rating, or what is the correct rating of RCCB that I need in my wiring? Actually, there are different ratings of the RCCB. So we have 30 milliamps, 100 milliamps, 300 milliamps, 500 milliamps, and so on. So now, which is which? 30 milliamp is the maximum amount of current that the human body can withstand without any serious health repercussions. All right. So anything above 30 milliamps may cause harm to the human body. And so when you are selecting an RCD to protect users, especially for domestic installations, the best RCCB you should be considering is an RCCB that is rated 30 milliamps. 30 milliamps is 0.03 amps. And so anytime there is an imbalance in the circuit, that fault current or that leakage current, in case a human being has contact with that fault part, before the current that passes through the human being to the ground is up to 30 milliamp, the RCCB should already have tripped to open the circuit to save the human being. And most of the times, some of these RCCBs are designed in a way that they trip even at lower amperes of the amount of current stated on the RCCB. And so with a 30 milliamp RCD, you are very safe. All right, so there are a few important things you need to know before we continue. Now, the RCCB purposely protects the users of the wiring against leakage. The miniature circuit breaker protects the circuit against overcurrent. Overcurrent can result from short circuit. Overcurrent can come as a result of overloading the circuit. And so for these two faults, the MCB is there to protect your circuit. The RCCB protects against leakage, but it does not protect against overcurrent. Oh yes, the RCCB cannot protect you when you have both live and neutral in your hands. And it can't protect you because so far as you are in contact with both live and neutral, whatever amount of current that is flowing through you flows through the live and goes back through the neutral. There is no difference. So you can equally die with your RCCBs in your circuit if you make contact with live and neutral. You should be aware. And because of this, when you are using RCCB, you must still use your MCBs. So for example, if you want to use an RCCB to protect a 3000 watt cooker, as I did in the example in my previous video, the one I titled How to Select the Correct Size of Circuit Breaker. In case you want to use an RCCB to protect that cooker circuit, you must still use the 16 amp breaker that is already connected in the circuit. So if you are using RCCB, you have to use the RCCB together with the miniature circuit breaker that should be protecting the circuit from overload and short circuit. So in that case, if you are a human being and you have contacts with maybe live and neutral, the RCCB will not operate, but because the MCB is there, you will still be saved from electrocution. All right, so in simple terms, the RCCB does not protect against overload and it doesn't protect against short circuit. It can only sense an imbalance in the circuit and then trip, so that anytime current wants to flow through a person to the ground, it will sense it and trip. Anytime there is a leakage that is capable of causing havoc in the electrical wiring, it will sense the imbalance and trip. But then, if you leave an RCCB in a circuit alone to supply power to your load, what you are doing is that you don't have any protection for the cables when there is a short circuit. And when the circuit is overloaded, you don't have anything to protect it. I said that you may see a 32 amp or 63 amps RCCB. The 32 amps there does not mean that when a current more than 33 amp flows through it, it will trip. No, it will not trip. That rating there is only guiding you to make sure that you don't subject that RCCB or you don't connect it in a circuit that will allow more than 32 amps to pass through it, because its terminals cannot hold current above 32 amps. That is exactly what it means. When you are installing an RCCB for a number of circuits, you have to make sure that the RCCB will be able to carry the total amount of current that all the loads require to work. And all the individual loads must still be protected with MCBs, miniature circuit breakers. If you want to know how to select the correct size of miniature circuit breaker for your individual circuits, you kindly have to refer to my video that I titled How to Select the Correct Size of Circuit Breaker. Now let's move to the RCBO. RCBO means Residual Current Circuit Breaker with Overload Protection. So in simple terms, it means the RCBO is a device that does all the things that RCCB does. And it also does all the things that MCB does. So it's like one device that is performing two functions. So it's a one device that performs both the functions of an RCD and the functions of an MCB. All right, so for instance, if you want to use an RCBO to protect a lighting circuit that requires a 6 amp miniature circuit breaker to protect that circuit, what happens is that you can use an RCBO that is rated 6 amps and can operate at 30 milliamps fault current. In the case of the RCCB, it is not like that. If you want to use an RCCB in a lighting circuit that is protected with 6 amp breaker, you add the RCCB to the MCB that is already there. So you are using both the RCCB and the 6 amp miniature circuit breaker, so that the miniature circuit breaker will protect the circuit from short circuit and overload, whilst the RCCB is protecting the circuit from leakage and is protecting the users from electric shock. All right, so by now, I'm very sure I have cleared many doubts and questions you have been asking about the RCD, what it does, how it operates, and how to select one for your electrical circuit. Well, I'm not done yet. There are more questions to answer about the RCD, and there are a lot of things to know about the RCD. The RCD, can it fail? Oh yes, it does fail. So how do you know that the RCD you have in your circuit is just a white elephant or is functional? There are times that if you don't take time, you have the RCD sitting in your wiring, but it's actually not protecting anyone from electric shock. How do I properly connect an RCCB in my electrical circuit? And how do I correctly connect an RCBO in an electrical circuit? I'll be answering this and many other questions in my next video, where I will be doing a practical demonstration to show you how these devices look like, how to identify them, and how to connect them properly in your wiring. Well, if you have learned something new from watching this video, tell me at the comment section how you felt about my video, and then kindly share to others also to benefit. And don't forget to subscribe if you have not done that yet, because there are many more videos that are coming that are very educative that can help you. Thank you very much. Hope to see you in my next video.